Hello, grade 8 students. In this video, we're going to start with a new lesson which talks about the greatest common factor and the least common multiple of two or more natural numbers. So our objective is to find the GCF or the GCD and LCM of two or more natural numbers. First of all, let us remember together what's the meaning of a prime factorization. So, every composite natural number can be decomposed into prime numbers. What does that mean? To decompose a natural number into prime factors is to try to divide this number by the prime number starting from 2. If 2 doesn't work out, then you go for the 3, and until you find the number which is divisible by the prime numbers. So let us remember together the criteria of divisibility before we continue. So you know that a number is divisible by 2 if the ones is even. You know that the number is divisible by 3 if the sum of digits is a multiple of 3. You know that a number is divisible by 5 if the ones is 0 or 5. And you know that it's, for example, divisible by 9 if the sum of digits is a multiple of 9. But all what I care about the criteria is 2, 3, 5, because these are prime numbers, 7, 11. So you should only divide by a prime number. So let us remember together the prime factorization. I'm going to take as an example 72, 90, and 84. For 72, you know that 72 is divisible by 2 because it's an even number. So when dividing 72 by 2, you get 36. So you put the 36 on the left side. Then you divide by 2 again, you get 18. Then you divide another time by 2, you get 9. 9 divided by 3 because 9, it's not divisible by 2. So we go for the 3. 9 is divisible by 3 and it's 3. Then 3 is divisible by 3, which is 1. So I keep on dividing until I get 1 at the end. So don't forget that this column is only for prime numbers. So now 72 is written as 2 to the power 3 times 3 to the power of 2. So that's the prime factorization in order to write 72 as a product of prime numbers only. So the prime numbers are to the power of something, it's okay, but they should be multiplied by each other. Let us take another example, which is 90. 90, it's divisible by 2, we get 45. 45, it's not divisible by 2, so it's divisible by 3, it's 15. By 3, it's 5. By 5, it's 1. So I keep on until I get 1 at the end. So 90 is written as 2 times 3 squared times 5. Now 84 divided by 2, it's 42. 42 divided by 2, it's 21. 21 is divisible by 3, it's 7. 7 is a prime number, so it's only divided by 7 until I get 1. So it's 2 squared times 3 times 7. Now, how do I find the greatest common divisor of the numbers after finding the or after doing the prime factorization method? So, to find the GCD of the three numbers using the prime factorization method, to find the GCD you have to find the common prime factors with the least exponent. So to find the GCD is to find, just let me highlight it for you. This is a highlighter. I'm gonna choose the green. To find the GCD, choose the common prime factors with the least exponents. Let us see what does that mean. I'm going to take as an example the three numbers 360, 200, and 756. For each of these numbers, I'm going to find the divisors and write them as prime factors. First, 360. By 2, it's 180. By 2, it's 90. By 2, it's 45. By 3, it's 15. By 3, it's 5. By 5, it's 1. So 360 is written as 2 to the power 3 times 3 squared times 5. Now let us find the divisors of 200. It's Of course, I advise you to practice this on a paper, then check your answers here. So 200, it's 2 to the power 3 times 5 squared. After finding the prime factorization of the two numbers, you have to find the GCD of the two numbers. So to find the GCD, choose the common prime factors with the least exponent. What are the prime numbers that are found in both numbers 2 and 3? Those are the prime numbers that are found in both, as you can see. The least exponent. So 2 to the power 3, 2 to the power 3, of course we're going to choose 2 to the power 3 because they are the same. But sorry, this is not 3. 5 is the common. 5 squared and 5, so what do you choose? You choose 5. So the GCD is 2 to the power 3 times 5. This is the GCD of the two numbers, the first two numbers. Now let us find the prime factorization of the third number. So the prime factorization of the third number is as you can see. Now you should search for the common divisor for both. Here I have 2 and 2. These are the only common prime numbers. So if we have 2 to the power 3 and 2 to the power 2, what do we choose? We choose 2 to the power 2. So the greatest common divisor for the numbers 360, 200, and 756 is 2 to the power 2. Now, how can I find the least common multiple of the two numbers? To find the least common multiple, it's the same thing. You have to find the prime factorization of the two numbers, find first the least common multiple of the first two numbers, then find it with the third number. And I'm going to highlight the most important. Okay, to find the LCM, choose the common prime factors but with the greatest exponents and not the common. So to find the GCD, we just explained it before, we have to search for the common prime factors with the least exponents only. But when it comes to the LCM, you have to search for the common, of course, but with the highest exponent. And then if there are any number which is not common, it's included in the least common multiple. So let us apply this. If we have 144, this is the prime factorization. Also the prime factorization of 600. Of course, I'm not going to explain it in details because we've already explained this. And also, let us find now the least common multiple. As I told you before, if you have any common prime number like 2, 3, let me just highlight it for you, 2 and 3, also 2 and 3. You have to choose the highest degree. So 2 to the power 4 times 3 squared. 5 is not common, so it's also included in my least common multiple. So it's going to be as follows: 2 to the power 3 times 3 to the power 2 times 5 squared. Okay, so this is the LCM of the two numbers. Now 1260, the least common multiple between those two, as you can see here, we have 2 to the power 3, here we have 2 to the power 2, so we choose 2 to the power 3. 3 to the power 2 and 3 to the power 2, of course, we're going to choose 3 to the power 2. 5 to the power 2 and 5, we're going to choose 5 to the power 2. And 7, it's not common, so I'm going to write it as well. So that's the LCM of the two numbers. Three numbers. Now, the relation between the GCD and the LCM of two natural numbers. You should always keep in mind that the multiplication of the two numbers, it's exactly the same as if you multiply the GCD with the LCM. And if two numbers are relatively prime numbers, then their GCD is 1 and the least common multiple is A times B. Of course, if you open a lecture, you're going to find a lot of exercises, a lot of solved exercises. I advise you to solve them. So open the lecture file, the PDF, check the numbers, all the exercises, try to solve them and check your solution. And if you have any question, just re-watch this video, because in this video I've explained everything that you need in solving GCD and LCM. So don't forget the prime factorization method, then you can find the GCD and LCM.